harder. Well, I don't know. The problems are simpler because you have to do 2 levels of them, but there's more to it because there's 2 levels of them. That's how you look at it.
Yes, I'm so mad about that. I'm not
Yes, sir.
mad about it because I gave it to her as a gift. Because I got it for sticks.
So it would look like this. They would say find d2y over dx2. If you ask me why it's written like that, I'm going to be completely honest and say I don't remember. So it doesn't matter. It doesn't affect the way you do it. Like, why aren't the 2's in the same spot? I don't know. So we're going to start with kind of the most common example here. There's just a couple little tricks that I want you to see, and we've talked about them a little bit already. But let's say I said x squared plus y squared equals 9. Find d2y over dx2. So find the second derivative is what that means. So you start off by finding the first derivative, and these will usually be simpler problems. So like what Joe was asking, is it harder or easier? Well, the difficulty level of the derivatives are easier, but you're doing it twice, so it's harder. So it kind of depends on which part you think is harder. So I'm going to go 2x plus 2y times dy dx equals 0, right? Let's solve that for dy dx. So I'm going to move the 2x over, and then normally you would factor and then divide, but you'd factor and then divide. There's nothing to factor, so I'm just going to divide by 2y. Those will cancel. And typically I would tell you, like, don't simplify. But because we have to go on, because we're going to take another step, the simpler we can make it, the easier that next step becomes. So I'm going to cross out those 2's. It's not like that's a giant risk. I don't think you're going to screw that up, but I always get surprised sometimes. By my own mistakes as well as yours. So this is the first root. Any more room? But I'm going to go over here, and we have to take the derivative of that. But let me back up. Any questions here on the first derivative? Worth, you all right? You see? We're good? Okay. So now when I take the derivative of this, the derivative of the left side is that d2y over dx2 thing. But what rule do I need for the derivative of the right side? I need quotient rule. So I have to do quotient rule, and within the quotient rule I have implicit differentiation. So the quotient rule is the second thing times the derivative of the first thing. Or the bottom times the derivative of the top, or holy high. Minus the top times the derivative of the bottom. So negative x times, well, what's the derivative of the bottom? dy dx, isn't it? Over the bottom squared. So y squared. So again, that's just quotient rule. And then with the implicit mixed in. So this is the bottom times the derivative of the top minus the entire thing. The top, which is negative x, times the derivative of the bottom over the bottom squared. Now here's my next step. Let's see if we can see where I'm getting this from. What did I do? Like, don't say it out loud, I guess. I mean, Look at it and see if you can see what I did. I know, Noah ruined it.
I didn't even get to think.
Russell put her hand up like a polite, classmate. Noah just blurted it out.
How am I learning?
You ruined her education. All of it. Do you see what happened though? What did you say? Go for it. I'll go out of the room if you want. Do you guys see what I did? So instead of the dy dx, I put negative x over y, and that's because up here I already know that dy dx equals negative x over y. All right? But you can't leave it like this because this is like it's a fraction over a fraction, which is not the form that they're going to want things in, not the form I'm going to want things in. So what we have, let's take another step and kind of simplify that. We have negative y. We have three negative signs, right? Negative, negative, negative. So it's negative x squared over y over y squared. I emphasized that so hard that I bumped the number. I was so excited about that. Fraction over fraction.
Wait.
Yeah.
Could I have a stupid question, but I don't know. Could I distribute the negative 1 into the other two? Why wouldn't I do that first?
This negative one?
No, down 1. Yeah, that. Can you distribute that into those two?
It's not distributive because this isn't like a plus or minus sign. So it's not like the negative goes to this and then goes to this. Just think about it this way. That's multiplication in there, right?
Yeah.
So what's a negative times a negative?
Positive.
And then you have the negative outside. Are we good?
Yeah.
You didn't really say anything. You just kind of ended our conversation silently. I wasn't sure what to do. We good?
Just cry for me.
Any questions to this point? Okay. So the next thing I have to do is handle this fraction over a fraction. So how many terms do I have in this problem? 3. 1 there, 1 there, 1 there. So to get rid of this y in the bottom, I'm going to multiply by a y on top. But if I do it to one term, I've got to do it to all the terms. So what that would look like is this negative y will just become negative y squared. And this y squared will become y to the third. So now what I have is negative y squared minus x squared over y to the third. Questions there? Anyway, I'm trying to show like a bunch of steps. That's why it's low. Go through this. Where'd you get this from? Joe.
So you multiply it by the top, right? Yes.
I multiplied that term by y,
Yeah.
which makes them cancel out, which gave me the x squared. But if I multiply that term by y, because I'm a fair, equitable person, I got to multiply. That used to be a y.
Yeah.
Multiplied it by y, now it's a y squared. I got to multiply this one too. That used to be a y squared. Multiplied by y, now it's a y to the third.
But why wouldn't it be x squared times y?
It is, but it's x squared times y over y.
I got you now. I'm thinking of
See, that's how you end a conversation. Thank you. Other questions? We're not done. Yeah, there's other stuff. Here's the answer. Figure out why. Don't say it, Noah. Shut up. You got it? I know, Rose just making the noise now. No. Actually, usually does it, but I think it's cool. Yeah.
Are we going to go to the third derivative?
No.
Can people go to the third derivative?
You could. You can go to the 80th. I mean, it doesn't matter. You just keep going. But hold on. So let me make sure we all understand what happened there. The original equation told us that x squared plus y squared equals 9, right? Wouldn't that also mean that negative x squared minus y squared equals negative 9?
Yes.
So that's all I did was substitute, if that equals negative 9, I can put a negative 9 in that spot. You usually don't have to do that. I just think it's cool. But I have seen it before on the AP test. But usually they don't make you do that extra step. And if you, like on my test, if you stopped here, it'd be fine. It's only on a multiple choice where they might have this, then you're like, wait a minute, what they do, and hopefully you can remember to like look to plug in.
I'm scared for the game. It's going to be like 7
At least I wouldn't mark it wrong though.
Yeah, but I'm not going to. It's going to get to the point where it's going to be one term and I'm going to, what do you want me to simplify?
This is separate, but your question about like infinite derivatives just reminded me of this. I want you to find the 63rd derivative of cosine.
Okay, I'll get started.
Already?
He's a liar.
Okay, yeah, I got it too. It wasn't spelled. Okay.
Alright. I'm going to need it for class period.
No.
One's trying to flex.
No, you're not. Start taking derivatives, see what happens. There's pattern.
Oh, okay.
I've seen this on the AP test too.
I channeled my energy into the Halloween goal and I was able to figure it out.
I'll leave that there during the AP test.
Wait, did we just take the AP test?
Yeah.
What did we do for stats, Andrew?
Like, I think that's really important. I don't know why other teachers don't do that. That you take the test in here because there's tons of research to say you test best where you learned, if you test where you learn the material.
Yeah.
There's also research that says you test best if you are in the same mental state as you learn the material. So if you're drunk when you come to class every day, please drink for the AP test also. Just keep it consistent. Yeah. If you're high right now, just be high for the AP. Alright, so, how many think they got this one? You figured out how to do it, but we're too lazy to actually do it,
Yeah,
is what you're saying?
I figured out.
So what's y first derivative? Negative sine, what would the second be? Negative cosine, what would the third be? And then the fourth, I'm just going to go 4, is cos. So the fourth is cos, so wouldn't the 8th be cos, and the 12th, and the 16th,
Yeah.
and the 64th? So what's the 6th? I forgot the X, but what's the 63rd?
Sign.
You signed. I want you, this is like very, very similar to the one we just did, but I want you to do one instead of just watching me do it.
I'm only on the third derivative.
Well, we've moved on, Joe. Did you watch what I did?
I think I heard it. Alright, is the answer negative?
Okay, do the problem. A-hole. I'm trying to get you to practice the process. I mean, I could put like 4x squared or something to make it like a little bit.
No, please don't. I was like, wait, this is the same thing.
It's the same problem. I understand that. I want you to practice the process.
You shut up.
Say it.
Shut up, Ashley. No one cares about it.
we'll do one that's just like doesn't work out this cool substitute back in way, just to give you one. I'll practice one of those, and then I'll get you your worksheet. Actually, I'll just give you the worksheet. We'll do number one in your worksheet. That's easier. So it sounds like most of you kind of know what the answers should be, so make sure you can get there.
How are you guys already done, man? I don't know why.
Wasn't this how you just No, it's gonna be.
I'm trying to follow this. I'm not gonna say that out loud. I clearly remember this.
Wait, is it multiple choice? Or do you have to do it for
Multiple choice.
Okay, how do you
Your like intonation freaked me out there. Is it multiple choice?
Well, I was
Or is it single
sure
choice?
I didn't know if we had to like
Yeah, it's multiple choice. Yeah.
Yeah, so it's like problem one. Problem one. I think I was trying.
There's only six.
I know this one. Oh, just kidding. Six times four is
All right, I want to go through. Quiet, please.
Oh man, I did it.
I want to go through this one. Just to make sure we got the process okay. So you got the first derivative is negative x over y, and then the derivative of that you need your quotient rule for. So the bottom times the derivative of the top minus the top times the derivative of the bottom over the bottom squared. And then this would be negative y minus negative x. And then what is dy dx? You got to look back at your first derivative. And that stuff happens every time. It's the very last step where we made a negative 9 that doesn't usually happen. But this one is always going to happen. And the example problem made a negative 9. Right? So negative y. I just wrote dy dx again, didn't I? So negative, negative, negative is a negative, and it's next negative x squared over y. I got y squared at the bottom. This is where we started getting rid of that fraction on top. So I'm going to multiply this by y, this term by y, which makes these cancel. Then I got to be fair and multiply this term by y, which makes it squared, and this term by y, which makes it cubed. So this is an acceptable answer. Like, you're done. That's correct. But we could go back and say, okay, negative y squared minus x squared is really negative 25. This is why some of you just shouted out the answer right away. But that's fine. But do you understand the process? Is what I'm trying to get to. Question on this one. All right. Let me do number one on here. So negative 2y times dy dx equals 6x, right? Because the derivative of 1 is nothing. So then dy over dx would equal 6x over negative 2y, which typically I would tell you don't simplify it, but because we have to work with it, the simpler it is, the easier it is to work with going forward. So I would put the negative on top, actually. I think that's easier for most of you guys. You can do it wherever, but I would rewrite this as negative 3x over y. You could also do 3x over negative y, but I think it's easier for most of you to put the negative on top. That's your choice. And then the second derivative is the product rule piece, quotient rule piece. So it's the bottom times the derivative of the top, so y times negative 3, minus the top times the derivative of the the bottom, so times dy dx over the bottom squared. You can see a lot of similarities, right? So we get negative 3y minus negative 3x times dy dx, which is negative 3x over y. Questions up to there? Where'd you get this? Where's this coming from? So then I think I would say, okay, that's negative 3y minus 9x squared over y squared. So a negative times a negative times a negative leaves me with a negative. And then 3x times 3x is 9x squared, and that y is on the bottom. But I don't want that y on the bottom, so I'm going to multiply this term by y, which will make those cancel. This term by y and this term by y. So I end up with negative 3y squared minus 9x squared over y to the third.
Because we can't plug in.
It's also that. Everybody tell me why it's that? That's the answer. You're fine. You're done. Okay, everybody tell me why it's that? You got it. Don't say it. Again, this isn't a required step. I just think it's cool. Your original problem was negative y squared plus 1 equals 3x squared. Couldn't I rewrite that as negative y squared minus 3x squared equals negative 1? Which would therefore mean negative 3y squared minus 9x squared equals negative 3. And then I would be able to plug in. So there's often this extra stuff that you can do, but you don't have to. Don't freak out if you don't understand that part. That's just me thinking it's interesting more than anything else.
Math is interesting.
How many see what I'm talking about here, though? Okay, cool.
See it.
So tomorrow when you come in, we're going to pretend it's the gateway. I'm going to say, here, take this gateway. You have, everybody quiet, no notes, anything. See what you can do. We'll check it and go over it. And I'll give you, how many practice tests I'm afraid to ask? How many
6.
practice tests do you want?
6.
3? Is 3 reasonable?
No, 6.
10 questions. And I'm not going to be here Wednesday, so you have Tuesday night and Wednesday night. I think 3 is fair. And I'll give you the answers, obviously, and then give you, you'll have time. If you have questions, you can email me. And then your first gateway is Thursday. At some point, it just becomes busy. I don't want it to be